Welcome back, students, in a new video where I'm going to discuss about the Plimsoll line and the center of buoyancy of a ship. When we were discussing about flotation and the laws of flotation, then there was a situation where we were discussing about the upthrust, and regarding to the upthrust, we were understanding that how any object used to float or sink partially or completely. So that we are going to discuss and understand for the condition of a ship. So let's start with that. We know for this thing that upthrust is the force which has been exerted by the fluid when any object been immersed wholly or partially in a given liquid. So when we are putting any object inside a liquid, whether it is water or any other liquid, then the object used to dislocate or displace some amount of liquid over there. And the amount of liquid that it used to displace, according to that or with respect to that one, it experiences an upthrust or the buoyant force. And when we compare the amount of this buoyant force with regarding to the weight of the object, then we can understand the situation that the whether that object is going to sink down in that given liquid or it is going to float over there. And when we understand about the situation of flotation, then we come across two basic things that once we say this thing that the object used to partially sink or it is completely sink or partially sink and partially floating and a proper flotation. So these things we had discussed under the condition of flotation in our previous classes. So when we were discussing about that, then we come to know about the buoyancy. And we know for this thing that the tendency or the property of a liquid that makes the liquid to exert an upthrust, that is called the buoyancy. And over there we know that it can be considered to be as a positive buoyancy or a neutral buoyancy or the negatively buoyancy or the buoyant force. So when we were discussing about this thing, then students used to have a confusion that what does this means partially floating and partially sinking, and what does a complete sinking means. So students, as I had explained earlier in my previous lectures, that when we observe that the body experiences enough amount of buoyant force that can balance the object on the surface of the water, then it can be considered to be as a positive buoyant force or positive buoyancy. If the body experiences equal amount of buoyant force as per to its own weight, then we say that it is a neutral buoyancy or the neutral buoyant force. And if the body experiences less amount of buoyant force than compared to its weight, then it is considered to be as negative buoyancy. So students, remember this thing, we always want to obtain the positive buoyancy, because when we go for the positive buoyancy or when we obtain for the positive buoyancy, then we can be on the surface of the water. Because while we used to float, when we make any kind of vessel to float on the surface of water or any liquid, then we want a major portion of that object to remain outside of the water. And to obtain that condition or to reach to that condition, we need to go for the positive buoyancy. Over here, only a small portion remains inside, means the portion which is inside or under the water, that is enough to generate the buoyant force, which would be equal to the weight of the whole object. So that what can happen, the object can easily float over there, and there would be no any particular problem. But if the buoyant force is almost equals to the weight of the object when it has been completely immersed, then under that situation we observe that it is a neutral buoyancy. So over here we can see that it is inside the water, but we can't say that it is completely floating or it is completely sink down over there. So we don't want to achieve this thing for every situation. There are some situations where we can go for this condition also for the situation of flotation, such as, for example, when we go for the situation of a submarine. When we study about the submarine, when we construct about a submarine, then a submarine need to be sometime on the surface of water, and it needs to be under the water also. So when we go for that one, according to the condition, we can change the situation by increasing or decreasing the weight of the body. But mostly when we go for any kind of ship or boat or any kind of yacht or any other vessel which we want to make float on the water, then we want to achieve this situation over here. Again, I want to repeat this thing, that the portion which is inside the water, it will generate enough amount of buoyant force which will be equal to the whole weight of the body, so that what would happen, the major portion of the body will remain outside of the water, and only a small portion will be inside the water so that it can float over there. So most of the ships or boats, whatever we used to see, or we use for different purposes, they have been made on the principle of this thing only. But submarines used to be using this principle. Whereas if the weight of the object is much greater than to the buoyant force, then what happens, the object gets completely sink down over there. Now, as I said earlier, that mostly we want to achieve for the positive buoyancy, but sometimes if it is required, then we can go for the neutral buoyancy also. But if the negative buoyancy is there, then it is confirmed that we are going to sink down over there. So when we discuss about a ship or a boat, then as I said that we want to carry different kinds of objects from one place to another place. So we don't want to go for this kind of situation. If this will be there, then what will happen? The objects will be sink down. The objects is not going to be dry. It is going to be underwater, and there will be a much problem over there. So the ships should go for this particular thing. So how could we determine that how much buoyant force it is receiving, or what is the right level till where the water should be there, so that the weight can be taken over there, or we can shift the object from one place to another place. So there comes the Plimsoll line. So Plimsoll line gives us an understanding where we can see that how much of that ship or boat should be inside the water, or how much it should be outside of the water. So when we see for a ship, then you can see that a portion which is under the water, which is present below the surface of the water, that is over there, which is called to be as the draft, and the portion which is above the water level, that is called to be as the freeboard. So we want to have a maximum freeboard so that it can be helpful for the ship to be sailed. Now, the Plimsoll line used to be determined by the scientific board, or the specific board who used to be constructing that ship according to the need over there. So over here, when we come for the need for the Plimsoll line, then we can say this thing, that Plimsoll line gives us a proper understanding that how much buoyant force the ship is going to receive with respect to the weight which has been given over there. So if we will put more load, what will happen? The ship will go down, and according to the Plimsoll line, we can determine that it should not go very low, because if it goes very low, then what would happen? The ship will sink down, or it will not be in a proper balanced condition. So this Plimsoll line gives us an understanding over there that with respect to the weight, do the water level is in a proper way, or the water level is very low or very high. According to that, it can change over there. So with respect to the volume of the water which is going to displace with respect to the load which is there, it will create a balanced situation, and it will not help the sink to that ship or that boat to sink down. Otherwise, what would happen, that if we overload it, if we put extra load, then what would happen? The body will not receive the enough amount of buoyant force, and it will sink down over there. So this was the use of this Plimsoll line. Now let's move for the next topic, where we are going to discuss about the center of buoyancy. So when we discuss about the center of buoyancy, or when we call for the center of buoyancy in a simple language, we can define for that the center of buoyancy of a ship is defined as being as as the geometrical center of the underwater volume of the ship at a particular instant, and is the point through which the total buoyancy or the buoyant force is considered to act vertically upwards. And this maintains the situation to make the ship be in a stable situation on the surface of water, and that lies along the line of center of gravity. Because if it changes its position with respect to the center of gravity, then what would happen? The ship will not be able to be constant on the water, because water is not a stable body. So if we want to make it in a stable situation, then its shape should be in such a way that the amount of liquid which it is going to displace, its centers should meet to the center of gravity of the body, so that they can be aligned with each other, and it will be safe for that ship to be sail over there. Let's understand more on this center of buoyancy with a graphical animation.
The center of gravity, or G, is the single point where the downward force of gravity acts. The center of gravity is the combined effect of the position and weight of everything on board a vessel. The center of gravity moves toward any added weight, away from any removed weight, and in the same direction as any shift in weight. On a properly managed vessel, the center of gravity should be maintained on the center line for maximum stability. Because it is a point in three-dimensional space, there are three coordinates used to describe its position. The vertical center of gravity, or VCG or KG, is measured upward from the keel. The transverse center of gravity, TCG, is measured from the center line. The longitudinal center of gravity, LCG, is usually measured from the forward perpendicular or from midships. Understanding where a vessel's center of gravity is located and how it moves is vital for a ship's officer, because it is the one property of a ship's stability that they have the most control over. As cargo is loaded or ballast tanks are filled, the center of gravity moves accordingly. How well an officer understands this principle will keep his vessel afloat in heavy weather. Center of buoyancy, or B, is the single point where the upward force of buoyancy acts. It is located at the geometric center of the displaced volume, or the area of hull beneath the waterline. When a ship rolls in the water, the shape of the area beneath the waterline changes. The center of buoyancy is constantly moving to stay in the center of that area. The key to understanding stability is understanding how the center of buoyancy moves. G and B have equal force acting in opposite directions. As a vessel rolls, the distance between the downward force of G and the upward force of B creates a righting moment that returns the vessel to the upright position. Trim is the difference in draft, forward and aft. The trim of a vessel can be found by reading the draft marks on its hull. These draft marks are placed as close to the perpendiculars as the shape of the hull allows. A vessel's freeboard is the vertical distance between the waterline and the highest watertight deck of the hull, usually the main deck. Freeboard is important because it is part of what determines the volume of the space above the waterline. The waterplane area, or AWP, of a vessel is the horizontal intersection of the waterplane and the vessel's sides. The bigger a vessel's waterplane area is, the greater the surface of the hull is that buoyancy will be acting against. For this reason, in the case of two vessels with the same weight added, the one with the greater waterplane area will have a smaller change in draft. As a vessel rolls in the water, its waterplane area increases as long as there is freeboard available to add to it. The larger a vessel's waterplane area becomes when it rolls, the more buoyant force it develops. This is why freeboard is indicative of a ship's reserve buoyancy, or additional buoyancy at larger angles of roll. Longitudinal center of flotation, or LCF, is the geometric center of the waterplane area. The LCF is the point about which the vessel trims. Note that the LCF is not necessarily located at midships. Its location is determined by the shape of the waterplane area and the trim of the vessel. Stability is the tendency of a vessel to right itself. When a vessel is tilted by an outside force, such as wind or waves, and it returns to its original position, it has positive stability.